So, first question, it says the coordinates of a square are A, B, C, and D. So make sure you remember that it is a square, so obviously 4 equal sides. It says the first coordinate is like 2, -3, so if we just do a little sketch of the graph, sorry, that should have been straight lines. We can see 2, -3 is going to be somewhere down here. That's going to be like A. We can see B is -2, -3, sorry, which is going to be -2, -3, going to be somewhere down here. That's going to be B. C is -2 and 1, which is going to be like here. So we can estimate that D is going to be here. So we can kind of see it's going to be horizontal from C and vertical from A. So it means it's going to have the X coordinate of A, which is going to be 2, and the Y coordinate of C, which is going to be 1. What are the coordinates of D? It's going to be 2 and 1. So it looks something like that. Next question, it says, does the point 2, 6 lie on the line y equals 2x plus 1? Remember, the first value is x and the second value is y. So what it's saying is, well, 2x plus 1 is equal to y, but y is 6, x is 2. So it's saying, well, is 2 times 2 plus 1 equal to 6? And we can say, well, 2 times 2 is 4, plus 1 is 5. It doesn't work, so it's no. It is not on the line. Same procedure with the next one. Substitute in, it's going to be x, so y is -3, x is -2. So you're going to get -3 is equal to -4 plus 1, which we can see does work, so it is on the line. And then same thing again, substitute in, y is 7, x is 2. So it would be 7 is equal to 4 plus something. Well, C would have to be 3, but we don't know what the value of C is, so we cannot tell. It could be, it could not be, we just don't know. Next question, it says, where on the graph with the line y equals 3x plus 4, cross the line y equals x minus 8. First thing you could have done is you could have drawn your lines. They would have gone something like this. And then that one would have been x minus 8, so it would have been something like this. And they would have crossed somewhere like that. Or what we could have done is said, well, we know that both of them are equal to y. So we know when 3x plus 4, we know it's going to be equal to x minus 8. Subtract x from both sides. 2x plus 4 is equal to minus 8. Minus 4 from both sides. 2x is equal to 4. Sorry, minus 4. So x is equal to -2. Now, it says where on the graph, so we need a coordinate. We know it's going to be -2 and something. So we need to substitute into one of the equations. So we know, for example, y is equal to x minus 8. So y is equal to -2 minus 8. Y is equal to -10. I know, Meredith, I agree. Okay, what is the gradient of this line? Pick 2 points. I'll pick one there and I'll pick one there. There you go. 1 across and 2 up. 2 over 1 is equal to 2. So the gradient is 2. Okay, next question. Same thing again. Pick 2 points on the line. Make sure you don't pick ones like there, because that's in the middle. Pick ones that are on the corner. Any of these ones that I'm drawing dots on, because they're on like the grid lines. Go right, then down. I can see I've gone 2 across and 1 down. But remember, it's y over x. So we can see the gradient is a half. Or, that's a decimal, 0.5. Okay, next question asks us to find the gradient. The gradient is, into the equation. First thing we do is find the gradient. We can see it's 1 and 2. So we know the gradient is 2. We can see the intercept crosses the y-axis at 1. So our equation is gradient of 2, intercept of 1. Same logic here. You can see it's the same question as before. We find our gradient, 1 and 2. So the gradient is 1 over 2. The intercept is 3, So the graph is y is half of x, sorry, minus half of x plus 3. That was a minus, sorry. Okay, which of these lines is parallel to f? F is this one here. We can see the gradient here is 1. So we're looking for another line with a gradient of 1, which is this one here. That also has a gradient of 1. We're looking for a. Because parallel m1 equals m2. The gradients are the same. Stop me at any point if you have questions. I know I'm talking quite fast. Next one, which of these two is perpendicular? So that means when we times the two gradients together, we should get negative 1. It also means if we divide negative 1 by one of the gradients, we get the other one. So we want perpendicular to C. So we say here's C. For C, the gradient is 2. So negative 1 divided by 2 is obviously negative 0.5 or negative a half. And we can see that B has a gradient of negative a half. The answer is B. Yes. Yes. Yes, I'm going to post it. Like I said in the thing, I'm going to post it into the comments of the post I put on today. No problem. Right. Question 12. Which of these lines is perpendicular to A? A, of course, is this one here. The gradient is 1. So if we say negative 1 divided by 1, of course, it's just negative 1. So we're looking for a gradient of negative 1. And we can see that that is D. Okay, it says which of the equations below give a line perpendicular. So again, that fact that we know that the product of the gradients has to be negative 1. First thing we do is we find the gradient of the line we have. We can see that the gradient is 1 divided by 3, which is 1 over 3. So therefore, the second gradient is going to be negative 1 divided by 1 over 3, which is 3. So we're looking for any line with a gradient of negative 3. So first one we can see, well, C has a gradient of negative 3. This one doesn't, this one doesn't, and this one doesn't. If we take this one here, we can also say, well, 2y can be divided by 2, divide by 2, divide by 2. And we can see that the gradient, again, is negative 3. So A is also a solution. Now we're looking for parallel. Again, parallel, we said, is the same gradient. So you find the gradient of the line on the graph. Well, it's the same as the one above. So we know the gradient is 1 over 3. So we can see no, no, no. None of those have a gradient of a third. It's none of the above. Which of these lines intersect line E at 0, 6? So what this means is that x is 0 and y is 6. It also tells us the intercept is 6. So we look at these lines here and say, well, this is C is negative 2, C is negative 6, C is 6, C is 2, and C is 6. So which of these lines intersect at 0, 6? Well, there's actually two options. You can have C or you can have E. Which of these lines, which of the following lines pass through both 2, 6 and 4, 14? So now we have to do a little bit of substitution. So I'd first of all say, okay, I'm going to take this first one. I'm going to say if for x is 2, I'd say, well, the first line A, sorry, I'm just going to start that again because that's messy. So I'd say, okay, well, if x is 2, y equals, and I'll do it for A, B, C, and D. So the first one, if x is 2, y is obviously 2 times 2 plus 2, which is 6. For the second one, it's going to be 4 times 2 plus 2, which is going to be 10. C, it's going to be 4 times 2, 8 minus 2 is 6. And D, 2 times 2 minus 2 is 2. So straight away I can see that B and D are out because they don't pass through 2, 6. So then I say, okay, I'll try the same thing. That when x is 4, I'll see what I get for y, for A and C, because I know that D and B can't work. So 2 times 4 is 8 plus 2 is 10. So A doesn't work here. And I'll just check C. 4 times 4 is 16, minus 2 is 14. I can see it is C. So that's some substitution. I repeat the same process for this one. For the next question, so again, try x is -1, see what y equals for the 4 equations, A, B, C, and D. So the first one, 2 times -1 is -2, plus 2 is 0, so A is out. 4 times -1 plus 2 is -2, so B is in. Then 4 times -1 minus 2 is -6, so C is out. And then I try D, 2 times -1 minus 2 is -4, so D is out, so therefore it must be B. Okay, next question. It says, what is the equation that passes through both 1, 1 and 4, 7? So the first thing we need to do is we need to find our gradient. We know it goes from 1, 1 and it becomes 4, 7. So we can say, well, the x value has changed by 3. The y value, sorry, that's changing y, sorry. Changing y is going to be 1 to 7, which is 6. So the gradient, we know, is changing the y divided by the change in the x. The gradient is 2. So we know it's going to be y equals 2x plus or minus something. So we need to figure out the something. So let's do the C next. So we know that the gradient is 2. But let's say we pick one of the points. Let's say we pick this one here. Well, in that point there, we know that x is 4 and y is 7. So into our equation, y equals mx plus c, we can say, well, y is 7, m is 2, and x is 4. So 7 is equal to 8 plus something, and obviously we need to subtract 1. So on the end, we can say it's -1. And that's how we do it. So we're going to repeat the same process for the next one. So I'm going to do this one here. So again, I want to find the gradient first. Always start with the gradient. We go -6, -4, and we become 10 to 4. So you can write change in x as this little what we call delta x. So change in x, it goes up by 16 from -6 to 10. The -4 to 4, well, that's going up by 8. So the gradient is going to be 16 over 8, which is going to be 2. So we know again it's going to be y equals 2x. That's nice. Then we need to find the intersection and the y-axis. So again, we're going to find C. So we say, well, let's pick one of the coordinates. I picked the second one before. I picked the first one this time. So x is -6. Ooh, terrible x. Y is -4. And m is 2. So I can say, well, y equals mx plus c as always. Y is -4. X is -6. Gradient is 2. So -4 is equal to -12 plus something. So the something is 8. So it's plus 8. Hold on, I've done something wrong there. That can't be right. I see what I've done wrong. There we go. So this is why your error check. All of that is wrong. Let's go back. Your gradient is not 2. That is a... See, this is why we check our answers. I knew I was wrong because I knew that was incorrect. So it's actually 1 over 2 because it's 8 over 16. So the gradient is half. So it's going to be y... Sorry. Negative 4 is equal to a half of negative 6 plus something. So negative 4 equals negative 3 plus something. C is equal to negative 1. That's still wrong. No, it's not. Half x. There we go. Now it's right. Okay, after that embarrassment, let's do the last one. Running out of room, but we'll make it work. Same process again. So find the gradient first. The gradient of the first line. So line A, m is going to be equal to, well, we've gone up 2 on the x-axis. We've gone down 1 on the y-axis. So the gradient is negative a half. Because we went from 3 to 5, which is 2, 10 to 9, which is negative 1. Then we find the intercept. So we say, well, y, let's pick the first coordinate. Y is 10, m is negative a half, x is 3. So it's going to be 10 is equal to negative 1.5 plus something. So c is equal to negative 11 and a half. Positive 11 and a half, sorry. But the gradient, of course, is the important bit because we're looking at perpendicular lines. We do the second equation. It says it's x is negative 4 and y is negative 4. And we need to know the gradient. It tells us they are perpendicular. So we're going to find m. We know the gradient of this one is negative a half. We need to multiply it by something to get negative 1. So negative times a positive is a negative. Half times 2. So the gradient is 2. So we know it's going to be y equals mx plus c. We know m and x and y are both negative 4. So it's going to be negative 4 equals 2 times negative 4 plus something. Something is 4. So the gradient is, well, the gradient was 2 and the intercept was 4. And that's your answer. Well, didn't do so well on question 19, but we got there in the end.